Good day, viewers all over the world. I welcome you to today's class. We are still on our series of the solution of system of linear equations. Solution of system of linear equations. Today we shall be looking at the Cramer's rule, TCR, the Cramer's rule for solving system of linear equations. Once again, I welcome you to today's class. My name remains Dr. Chris Esekaibe. I'm the owner of this YouTube channel, Dr. Chris Esekaibe. The essence of the channel is to teach key topics in mathematics and statistics. Where students have difficulties, we bring the topics, we teach them and upload them and break them down for easy or easier understanding. I am a chief lecturer in one of the most prestigious polytechnics in Nigeria. I hold a doctorate degree in mathematics with distinction, a master's degree in mathematics, and also a bachelor degree in statistics. I have scholarly publications at a national and international level, and I've also presented papers in national and at national and international conferences within and outside Nigeria. I've written quite a number of books. I've written books in numerical analysis, applied statistics, in geometry, in trigonometry. Why not? And I'm also a member of the Nigerian Mathematical Society. I'm also a member of the Nigerian Statistical Association. Why not? If you are a research institute or a research firm or an AI firm, you do a lot of artificial intelligence or research work, you can consult me or contact me to be team or part of the team of your mathematicians and statisticians. I will be glad to be part of what you are doing. My contacts are +234 80 21903. This first number is for WhatsApp. Then the second number is +234 70 297535. This one is only for call. And my email is here, chrisdavid2015@gmail.com. I will be looking forward to hearing from you so that I can be part of what you are doing. And please, if you have not subscribed to my YouTube channel, please subscribe to my YouTube channel. Click on the notification button, the bell button, so that anytime I upload a new video, you will have a notification. Share my videos in your social media platforms, share them and like them. And as you do, God will bless you. Be part of those sharing knowledge across the globe. The essence of this channel is to share key knowledge in mathematics and statistics across the globe. So be part of those sharing the knowledge. Thank you very much. Now it is time we go to the business of the day. We are still on our series, Solution to System of Linear Equations. Permit me to clean this part of the board so that we can focus on the agenda for today. Solution to the system of linear equations, or solution of system of linear equations. Today we are looking at the Cramer's rule. The Cramer's rule is a method or a rule that uses a determinant to solve a system of linear equation. It uses determinant. If you are conversant with matrices is a special topic that cuts across various fields of study. Likewise, a solution to system of linear equations. In different fields of studies, in engineering, in sciences, in business, in architecture, in medicine, you will come across a system of linear equations to be resolved. And basically, there are two groups of methods: the direct methods of solution and the iterative methods of solution. All the methods we have been looking at since this series started, all the methods are direct methods of solution. The first video uploaded for this series, we looked at the matrix inversion method. The second video we looked at the Gaussian elimination method. The third video we looked at the simple elimination method. And the last video uploaded we looked at the simple substitution method. This is the fifth method we shall be looking at, and this is also a direct method. So we are looking at the Cramer's rule for solving system of linear equations. This is an example of a 3 by 3 system. A11x1 plus A12x2 down to B1, this is equation 1. A21x1 plus A22x2 down is equal to B2, equation 2. And A31x1 plus A32x2 plus A33x3 is equal to B3. That is our equation 3. Now, putting this particular system in matrix format, you will see that we can bring a square matrix out, A. Now, A is a square matrix, the coefficients of the unknowns. The unknowns here are 3, x1, x2, and x3. They are the unknowns. Then the 3 equations, that's why we call it 3 by 3 system. Having 3 unknowns in 3 equations. So now what we have here, we are going to pick out the coefficient of the unknowns to form a matrix, a square matrix, a non-singular matrix. A non-singular matrix is a matrix whose determinant is not equal to 0. The determinant of A must not be equal to 0. Then they look at the unknowns, x1, x2, x3, then the right hand side. When you see a capital letter having 2 bars beneath it, it is a matrix. The first bar for the rows, the second bar for the columns. Then when you see a capital letter having just 1 bar, it is talking about a vector. X here is a column vector, while B, which is the right hand side, is also a column vector. So this is the matrix format for this 3 by 3 system. Now, before we apply the Cramer's rule, we are going to get series of matrices. Now, the first one we have gotten our A to be this. Now we are going to get our A1. Our A1 will now be equal to, this is the first column of A, the second column of A, the third column of A. To get your A1, you are going to replace the first column of A by the right hand side. So the right hand side, you write it first to replace A11, A21, and A31. So you are going to have B1, B2, and B3. Then other entries will be there. You now have your A12, A22, and A32. Then you have your A13, A23, and A33. This is our matrix A1. Then we are going to have our A2. Then for us to get our matrix A2, you are going to use this right hand side, which is B, to replace the second column of A. So you will first of all write the first column of A, A11, A21, A31, which is this first column. Because it is A2, the second column will now be replaced with the right hand side. This will be B1, this will be B1, B2, and B3. Then of course the third column will be written A13, A23, and A33. This third column is written there. This will now form our matrix A2. Then again, because it is a 3 by 3 system and it has 3 columns, for each matrix, new matrix you are forming, B will be replacing each column for each matrix. Then the A3, which is the third one, now you are going to use this right hand side to represent the third column. You will now write the first 2 columns of A. You have your A11, your A21, and your A31. Then the second column is there, A12, A22, and A32. Then the third column, because it is A3, you are now going to use the right hand, which is B1, B2, B3, to represent the third column. You now have your B1, your B2, and your B3. So this is how you get. Now we have gotten 4 matrices: A, A1, A2, and A3. That is what we have gotten. We have gotten matrix A, matrix A1, matrix A2, and matrix A3. Now, by Cramer's rule, how do we now get the unknowns? The first unknown there is x1. So x1 will be equal to the determinant of A1 all over the determinant of A. Then our x2 will be equal to the determinant of A2 all over the determinant of A, while our x3 will be equal to the determinant of A3 all over the determinant of A. That is what we are going to get all through. So you can see that the Cramer's rule makes use of determinant. Now we have 4 matrices: A, A1, A2, and A3. Now, when you now want to get these unknowns, x1, x2, x3, you now make use of the determinant of the 4 matrices, but each is divided by the determinant of A. So if you want to get x1, you will say you will get the determinant of A1, you divide it by the determinant of A. If you want to get x2, you get the determinant of A2 divided by the determinant of A. If you want to get x3, you get the determinant of A3 and divided by the determinant of A. Meaning that we are going to get the determinant of each of the 4 matrices formed from this 3x3 system of linear equations. It is as simple as that. Now you permit me to go to that same example. There is an example that we have been solving. That example is unique and it is consistent. A 3x3 system that is unique and consistent. So what has been explained here, we are going to replicate it into solving a practical problem. A practical 3x3 problem. We have used 4 different methods to solve that same problem. We got x1 to be equal to 1, x2 to be equal to 2, and x3 to be equal to 3. For all methods used, we got that same answer, that same set of solutions, meaning that this particular system we are talking about is consistent, is unique, and independent. So a system of linear equations is said to be consistent and unique if it has only one set of solution. One set of solution. No matter the method used, you will arrive at that particular set of solutions. So now, let us go ahead and solve that same problem. Permit me to clean this, take note of this. So permit me to clean all this so that we can go straight to that particular problem and use the Cramer's rule to solve that particular system we have been solving from the beginning. To solve that particular system. I hope you have taken note of how the Cramer's rule works. Now this is the system. It is 3x1 plus 3x2 plus 5x3 is equal to 24. 3x1 plus 5x2 plus 9x3 is equal to 40. Then you have 5x1 plus 9x2 plus 17x3 is equal to 74. This is the system we have been solving. This time around, we are going to put this first of all in a matrix format. We are going to put it in a matrix format. Permit me to do that. Please, once again, subscribe to my YouTube channel if you have not done that. Click on the notification button and so that anytime I share a video or upload a video, you will be among those to have a notification. Like my videos, share them on your social media platforms, and as you do, God will bless you. Be part of those that are sharing knowledge. So now, let us continue with our teaching. Now, I want to put this particular system in a matrix format. So I'm going to have the matrix A first, the coefficient of the unknown 3, 3, 5, 3, 5, 9, 3, 5, 9, then the next one 5, 9, 17, 5, 9, 17. This is the matrix A. Then the unknown are x1, x2, and x3. Then we have our right hand to be 24, 40, and 74. This is the right hand side. So this will be our matrix A, which is a matrix. Our unknown will be x is a vector, and our equation sign there, of course, there is a dot sign there, which is for multiplication. And this will be our B, which is the right hand side, and it is a column vector. That is the matrix format. So this is our A. So meaning from here, our A is equal to 3, 3, 5, 3, 5, 9, 5, 9, 17. Now our A1, now to get A1, we are going to replace the first column of A with B, which is the right hand side, as we did earlier. So the first column will be replaced, that will be 24, 40, 74. Then the other part of A will be written, this will be 3, 5, 9, this will be 5, 9, 17. This is our A1. Then now our A2 will now be equal to, for us to get our A2, we are going to use the right hand side to replace the second column. The second column is 3, 5, 9. So we are going to replace it. So we are, first of all, let's write the first column. The first column is 3, 3, 5. Then the second column, because it's A2, it will now be replaced by the right hand side. That will be 24, 40, and 74. Then of course the third column of A will be written, which is 5, 9, and 17. This is our A2. Then our A3, we are now still going to use the right hand side to replace the third column. So we write the first two columns of A, 3, 3, 5. Then the second column is 3, 5, 9. Then for A3, we replace the third column of A with the right hand side, which is 24, 40, and 74. So this will be our A3. I come again. Our A is the coefficient of the unknowns in the left hand side of the main problem of the system. Our B is the right hand side. Then our unknowns are the x1, x2, and x3, because we are considering a 3 by 3 system. So we have 3 unknowns in 3 equations. Equation 1, equation 2, equation 3. So we brought out our A. When you are using the Cramer's rule, you get other, apart from matrix A, you get other 3 matrices, so that you can see the unknowns are 3. So the first matrix, we call it A1. How do we generate A1 from A? Now you replace the first column of A with the right hand side. That is what we did. 24, 40, 74, replacing this. Then you put the other 2 columns. Then to get matrix A2, you replace the second column of A with the right hand side. You can see this 3, 5, 9 has been replaced with 24, 40, and 74. The first column and the third columns were retained. Then to get matrix A3, you are going to replace the third column. You can see the first 2 columns, 3, 3, 5, 3, 5, 9 were there. Then the third column, 5, 9, 17 will be replaced by the right hand side. So now that we have gotten this, our next step, because the Cramer's rule makes use of determinants. The Cramer's rule makes use of determinants. If you have done a topic in linear algebra that is known as matrices, we have what we call a determinant of matrices. A determinant is a single value that is computed that describes a matrix, and the matrix must be a square matrix. You can only get the determinant of a square matrix. you can see that our A is a square matrix, a 3 by 3. That means, what do you mean by a square matrix? A square matrix is a matrix whose number of rows and number of columns are the same. Here, the number of rows, 1, 2, 3, 3 rows, columns, 1, 2, 3, 3 columns. So it's a 3 by 3 matrix. So it's a square matrix. A matrix who has the number of rows equal to the number of columns is a square matrix. And you can only get the determinant of a square matrix. The determinant of a square matrix can be 0, it cannot be 0. If the determinant of a square matrix is 0, that matrix is called a singular matrix. If the determinant of a square matrix is not equal to 0, that matrix is called a non-singular matrix. Meaning that A must be a non-singular matrix. The determinant of A must exist, it must not be equal to 0. Because if you can remember vividly, when I was describing this method, we were for us to get the unknowns, we were dividing all through by the determinant of A. And if the determinant of A is 0, you cannot divide by 0. In mathematics, when you are dividing any number by 0, it is undefined. So the determinant of A must not be 0, and A must not be a singular matrix. It must be a non-singular matrix before the Cramer rule can work. Before the Cramer rule can work, A must be a non-singular matrix. Now, permit me to go ahead and let us get the determinant of A. Determinant of A will now be equal to, now you are going to put this in a cofactor. Now look at the first one here. If I keep this 3, I will have 3. Then this row will go, this column will go, and we have 5, 9, 9, 17. Then of course, minus is plus, minus, plus. So the next one will be minus 3. Then you take the cofactor of this 3. This will go, this row will go, this column will go. I will have 3, 5, 9, 17. 9, 17. Then plus the third one, which is 5. Then I will take the cofactor of that. This row will go, this column will go where this 5 is. So I will now have 3, 5, 5, 9. I will have 3, 5, 5, 9. Then I have that. Now I can now go ahead to get my determinant for A. Now you come here. So our determinant of A will be equal to 3 into 17 times 5. 17 times 5, you are going to get 85. Then 9 times 9 minus 81. Then you put minus 3 into 17 times 3 is 51. Minus 5 times 9 is 45. Then plus 5 into 9 times 3 is 27. Minus 5 times 5 is 25. So when you come here now, our determinant of A is equal to 3 into 85 minus 81 is 4. Minus 3 into 51 minus 45 is 6. Then plus 5 into 27 minus 25 is 2. So you are going to have 3 times 4 is 12. Minus 3 times 6 is 18. Then plus 5 times 2 is 10. Plus 10, and that will give us 4. So determinant of A is 4. Determinant of A is 4. Now we are going ahead to get the determinant of A1. So determinant of A1 will be equal to, look at it here, we hold this first value, this will be 24, you take the cofactors of 24, this row will go, this column will go, because 24 is in this column, 24 is in this row. So you have 5, 9, 9, 17. 5, 9, 9, 17. Then of course the next one is minus 3. Then you take the cofactor of 3. This row will go, this column will go. You have 49. You have 49, then 74, 17. Then the last one is plus 5. Then you take the cofactor of 5. This will go, this will go. So you have 45 here, then 74, and you have 9. Then that is what you have. So our determinant of A1 will be equal to 24 into 17 times 5 is 85. 17 times 5 is 85, minus 9 times 9 is 81, then minus 3 into 17 times 40. 17 times 40 is 680. So you have 680 minus 74 times 9. 74 times 9 is 666. 666. Then you close the bracket, plus 5 into 9 times 40 is 360, minus 74 times 5. 74 times 5 is 370, minus 370. You have that. So our determinant of A1 is equal to 24 into 85 minus 81 is 4. 24 into 4 minus 3 into 680 minus 666 is 14. Then plus 5 into 360 minus 370 is minus 10. So this will now be 24 times 4 is 96. 96. Then minus 3 times 4. 3 times 14 is 42, minus 42. Then of course you can see this is 5 times minus 10. Of course it will be minus 50. So you go, this will now be 96 minus 92. That will be 4. So our determinant of A1 is also 4. So beloved, I hope you are following. We have got the determinant of A. We have got the determinant of A1. Determinant of A is 4. The determinant of A1 is also 4. Now permit me to go ahead and clean these determinants so that we can go ahead and get determinants of A2 and determinants of A3. They will now come back to get our unknowns. So take note, determinant of A is 4. I hope you can see, you have taken note of that. The determinant of A1 is also 4. So permit me to clean it so that we can continue with the determinant of A2 and determinant of A3. So that we can now come and get the final solution of values for x1, x2, and x3. Now let's go ahead. Determinant of A2. Okay, let me write it in capital letter. Determinant of A2 is this. We are using, this is our A2. So you hold your 3 first. What are the cofactors of 3? This will go. This will go. You have 49, 74, 17. So you have 49, 74, and 17. Then of course, minus 24. What are the cofactors of 24? This column will go, this row will go 3, 9, 5, 17. So you have 3, 9, 5, 17. Then plus of course, the last value there on the first row is 5. Then what are the cofactors of 5? This column will go, this row will go. You have 340, you have 340, 340, 5, and 74. So now we are good to go. So our determinant of A2 will be equal to 3 into 17 times 40. 17 times 40 is 680 minus 74 times 9. 74 times 9 is 666. You close the bracket, minus 24 into 17 times 3 is 51. Minus 5 times 9 is 45. Then plus 5 into 74 times 3. 74 times 3 is 222. 222 minus 5 times 40 is 200. Then you close it. Then our determinant of A2 will be equal to 3 into 680 minus 666 is 14. Minus 24 into 51 minus 45 is 6. Then plus 5 into 2 minus 200 is 22. So our determinant of A2 will be equal to 3 times 14 is 42 minus 26 times 6 is 144, then plus 5 times 22 is 110. You take this, you are going to have 8. So the determinant of A2 will be equal to 8. You take note of that. Now let's take the determinant of A3. This will be equal to, look at our A3 here, this will be 3. The first value in the first row is 3. Then what are the cofactors? This will go to be 540. It will be 540, 974. Then of course minus 3 into this one will go, we have 340. We have 340, 574. Then plus the last value there is 24. Then what are the cofactors? This will go, we have 3559, 3559. That's what you have there. So here now, we are going to have determinant of A to be equal to 3 into 74. Determinant of A3. Determinant of A3 will be equal to 3 into 74 times 5. 74 times 5 will be 370. It will be 3 into 370 minus 9 times 40 is 360. Then minus 3 into 3 times 74. 74 times 3 is 222. 222. 5 times 40 is 200 minus 200. Then plus 24 into 9 times 3 is 27. Minus 5 times 5 is 25. So you go further, you are going to see that you are going to have 3 into 370 minus 360 is 10. Then minus 3 into 222 minus 200 is 22. Then plus 24 into 27 minus 25 is 2. So you have that. Then at the end of the day, when you carry out this will be 30 minus 66 plus 48. You are going to have the determinant of A3. Determinant of A3 will now be equal to 12. If you carry out this arithmetic, this will be 30 minus 66 plus 48. So the determinant of A3 will be equal to 12. So permit me, we have gotten the determinant of A2 and determinant of A3. Permit me to now clean this part of the board so that we can go ahead and get our unknowns. Now I want to bring out the summary of the determinants, the summary of all the determinants. Let's write it out. Determinant of A is equal to 4. Determinant of A1 is equal to 4. Determinant of A2 is equal to 8. Determinant of A3 is equal to 12. Now that is the summary of the determinants of the 4 matrices A, A1, A2 and A3. Now remember from what we did, our x1 is equal to determinant of A1 all over determinant of A. So determinant of A1 is 4, this will be 4 all over 4, and that will be equal to 1. Determinant of A1 is 4, determinant of A is 4. So 4 over 4 is 1. Now our x2 will be equal to determinant of A2 all over the determinant of A. What is the determinant for A2? Determinant of A2 is 8 all over determinant of A is 4. 8 over 4, that will be equal to 2. Then lastly, our x3 will be equal to determinant of A3 all over determinant of A. Determinant of A3 is 12, this will be 12 all over determinant of A is 4, and that will be 3. So by summary, this implies that our x1 is equal to 1, our x2 is equal to 2, and our x3 is equal to 3. You can see, beloved, we have arrived at this same answer again. We have arrived at this same answer again, this set of solutions. We use the matrix inversion method, we arrive at this set of solutions. We use the Gaussian elimination method, we arrive at this set of solutions. We use the simple elimination method, we arrive at this set of solutions. We use the simple substitution method, we arrive at this set of solutions. Today, we have used the Cramer's rule, and we have also arrived at this particular set of solutions. You can see the beauty of the system of linear equations. We have been using direct methods. This is the 5th direct method that we have used in solving this same system of linear equation. This is a series. It's a series of solution of system of linear equations, and we have successfully used 5 direct methods of solution. And you can see that each of these methods gives us the same set of solution. It means that the system of linear equation is unique, is consistent, and it is independent. This makes the system independent, it makes the system unique, and it makes the system consistent. I believe you have learned 1 or 2 things. Let me do a summary of the Cramer's rule. The first thing you bring out, you put the system of linear equation. It can be a 4x4 system, it can be a 5x5 system, it can be a 6x6 system. First of all, you put the system in the matrix format. Ax equals b. A is the square matrix from the coefficients of the unknowns in the left hand side of the system, while b is the right hand side of the system. So the matrix format will be Ax equal b. Now that you have brought your A out, you are going to get 3 other, because this system that we saw is a 3x3 system, having 3 unknowns in 3 equations. That's why it is called a 3x3 system. Now that you have A separately, matrix A must be a non-singular matrix. A non-singular matrix, before you can get the determinant of a matrix, that matrix must first of all be a square matrix. And for you to use the Cramer's rule, the matrix A must be a non-singular matrix, meaning that the determinant of matrix A must not be equal to 0. So when you have gotten matrix A, you need to get three other matrices, because the system is a 3 by 3 system. When you want to get the next matrix A1, you replace the first column of A by the right hand side. You want to get the second matrix A2, you replace the second column of matrix A with the right hand side. Then to get the third matrix A3, you will replace the third column in matrix A with the right hand side. Now you will now get the determinants of these four matrices. A inclusive, A making it 4. A1, A2, and A3. You get the determinant of A, get the determinant of A1, get the determinant of A2, get the determinant of A3. Then by matrix, by Cramer's rule, for you to get each of the unknowns, you are going to be dividing the determinant of the A1, the A2, the A3, the A4. Each of them, if it is a 6 by 6 matrix, if it is a 6 by 6 system, you are going to get a 6 by 6 matrix. That means you are going to get A1 to A6. If it is a 10 by 10 system of linear equations, after you have brought matrix A out, you are going to get other 10 matrices, A1 to A10, and you are going to get the determinant of all the matrices. That means each matrix represents each unknown. A1 now, for instance, represents x1, A2 represents x2, A3 represents x3. For me to get my x1, I will divide the determinant of A1 by A. For me to get my x2, I will divide the determinant of A2 by A. For me to get my x3, I will divide the determinant of A3 by A. If it gets to x4, x5, if I want to get x4, I will divide the determinant of A4 by A. If I want to get x5, I will divide the determinant of A5 by A. If I want to get x10, I will divide the determinant of A10 by A, and so on and so forth. So A is a square matrix, and from A you will get A1, you will get A2, and you get A3. You will not get beyond A3 because it is a 3 by 3 system for this particular problem. If it is a 4 by 4 system, you will get A4. You will get up to A4. If it is a 5 by 5 system, you will get up to A5. If it's a 12 by 12 system, you will get up to A12. And if you want to get each unknown, that means each of these matrices representing the unknown. So x1, for you to get x1, you will divide the determinant of A1 by A. For you to get x2, you divide the determinant of A2 by A. For you to get x3, you divide the determinant of A3 by A. For you to get x10, you divide the determinant of A10 by A, and so on and so forth. This is the reason why the determinant of A must not be 0. That means A must be a non-singular matrix. This is the Cramer's rule for you. I believe you have learned how to use the Cramer's rule. If you are given a 4 by 4 system, a 7 by 7 system, you now know how to go about it. Thanks again for your patience, for watching my video to the end. Please subscribe to my YouTube channel, Dr. Chris Esekagbe. Click on the bell button for notification, so that anytime I upload a video, you have a notification. Share my videos on your social media platform, and also like my videos. If you are an artificial intelligence firm or a research institute that does a lot of research, why not you can consult me? My contacts are at the beginning of the video. I'll be expecting to hear from you. I'll be expecting to partner with your to work with your team of mathematicians and statisticians. And God bless you for watching today's video. Expect to see you in my next class. In my next class, I'll be coming up with, we are still on the series of solution of system of linear equation. I will be coming up with another direct method of solution known as the Koleski's algorithm. Watch out for that. God bless you. Have a nice day. Bye.